neck blouse. Drafting, cutting and stitching. This is the typical women's garment with an inner lining. There is the front side with a single strap around the back of the shoulder. No sleeves in this style. The back side of the garment is tied with a narrow placket opening at the bottom. Paper pattern drafting. Measurements. Materials. Instructions for drafting. Draw the drafting of halter neck blouse, front, back and placket on the brown sheet. Place center front and center back matching with shoulder slope line. Draw the halter neck shape from center back to front armhole. Draw the back shape. Instruction for master pattern. Add the given allowances to the paper pattern components for seam allowance and turnings. Cut the excess brown sheet through the cutting line to get the master pattern of halter neck blouse. Layout and cutting. Lay the fabric and lining cloth on the cutting table on widthwise folding with wrong side facing upwards. Place the master pattern of halter neck blouse economically without wasting the fabric. Mark the outline of components and dart position. Cut the components with lining material. Halter neck blouse. Stitching. Style features. Materials and trimmings. Take front part and lining piece with right sides matching together. Stitch darts on the marking. Stitch around armhole and neck on seam line. Stitch bottom with seam allowance. Turn the front piece to right sides by side gap. Give top stitch around neck, armhole and bottom. and lining with right sides matching together. Stitch darts on marking. Stitch on top and bottom. Turn the back piece to the right side by side gap and give top stitch. Join front and back sides with self-bound seam. Finish the back open with falls and extend. Mark hooks and eye position at back neck and placket open. Fix hooks and stitch eyes. Finish and press. Students, in this exercise, you have learned how to draft, cut and stitch the halter neck blouse. We have completed all the exercises of tailor lady's trade. I hope you have enjoyed this video instructional program. I wish you all the very best in your career. Thank you.
When we are talking about air conditioning, what do we mean by this term? Conditioning air. This basically means that we are transferring the heat from within the space to the atmosphere outside. This air conditioning is the source of comfort, it improves the efficiency, and it is healthy for the inmates of the air-conditioned space. It is a proven fact that air conditioning brings comfort to the inmates of the conditioned space. That is the reason why today hospitals, hotels, shopping malls, you name it, are totally air conditioned. Today, air conditioning is a lot more affordable to the middle class families. As a result of this, there is a huge turnout in sales. To support this sales, we need a good backup service. To this goal, we need well-trained technicians. The purpose of this instructional presentation is to train the technicians in the repair and maintenance of window and split air conditioners. Joining two pipes of the same diameter would be possible only if one pipe diameter was larger than the other. To do this, we swage this diameter so that it fits into the other. Now let's see how it's done.
Switch and prepare copper tube joints for window and split AC. Required tools: flaring block, swedging tool, hammer of 225 grams, blow lamp or gas welding set. Materials: brazing rod, flux, small quantity of oil, cotton waste, matchbox or lighter, and 2 copper pipes.
How to switch the end of the pipe? To join two pieces of pipe of the same size together, one must be made larger so that the other fits inside. Place the pipe in the tool. Make sure that you have chosen the correct size hole to fit the pipe. Position the pipe so that the end is the outside diameter of the pipe plus 1/8 inch. Choose a punch of the right size to switch out the end of the pipe. Oil the punch. Fit the clamp and punch into the swaging block. Force the punch into the pipe. Remove the pipes from the swaging block. Another piece of pipe can be fitted into the swaged end. Now we've seen the process of swaging done of the two pipes. We'll go into brazing the two pipes together so that forms a leak-proof joint. Now let's see how it's done. Emery the surface of the pipe so there's a smooth surface for the joining. Join the pipes neatly together. Apply a little bit of flux. Mix it with a little oil and make a stiff paste. Apply a small amount of the flux to the surface to be brazed. Only a small amount need to be applied. Too much will contaminate the system. Push the pipe as far as possible. Turn the pipe to spread the flux. Start your brazing torch. Use the right size, which is only blue in color. A yellow flame should be avoided as it will oxidize the pipe and leave a trace of fine carbon on the pipe surface. Heat the pipe till it turns bright red. Keep testing for this while the heating is going on, touching the heated pipe with the brazing rod. At this point, the brazing rod at several points around the circle will start melting. The molten brazing rod will be drawn into the fine space with two pipes. When a complete ring of brazing material can be seen at the end of the swage, remove the brazing torch. Allow the joint to cool. Do not disturb the pipe until the brazing material has hardened. Clean the surface and examine the joint carefully. There should be no sign of any pinhole or leak. Now we have seen how a swaging joint is brazed and jointed together. But this is not the only joint in refrigeration. We also use what is termed the flare connection, which connects the pipe to a flare to a joint or a threaded joint where it connects to another flare and a pipe. Now let's see how this flaring can be done.
Flare and prepare copper tube joint for window AC. Required tools: flaring block with yoke, adjustable wrench 200 mm, valve key 6 mm, pressure gauge with adapter, flat file smooth 200 mm, cylinder with pressure. Materials: copper tubes, flare nut 6 mm size, thread seal tape, soap solution with stirrer, and small quantity of oil.
Before making a flare connection, ensure that you have a smooth and clean surface. Use a file to clear out any rough burrs that may come. Take a flare nut and slide it down the pipe. Clamp the pipe in the yoke. The distance that is necessary between the top of the yoke and the pipe is the pipe diameter divided by 3 if it is in mm. Fit the yoke on the block and adjust it so that the flare comes directly on the pipe. Now slowly screw the yoke till the cone expands the pipe into a flare in the shape of a block. Remove the pipe from the block. Examine the flare. If the flare is cracked, this implies that the screw down too quickly. Ensure that the flare is of the correct size. If it is too loose, cut it off and redo the operation again. This flare is done on one side. The similar joint can be done on the opposite side. Notice that we have done no brazing. This is completely a mechanical process, and the tightening of the flare nut ensures that it is absolutely leak proof.
Identify all components, controls with their specifications and function of window and split AC. Required tools: trainee's kit and a line tester. Equipments: complete system of window and split AC.
The major component, like I mentioned, was the compressor, which is the heart of the system, the evaporator, which draws the heat from the room, the condenser coil, where the heat is rejected, and the capillary tube between the two. In addition, we have the strainer dryer, which attached before the capillary. You have the fan motor, which drives the blower, and the condenser. So on this side we have the condenser fan, and on this side we have the blower. Now housing the blower is the bulkhead, and around the fan is the shroud. The first item we are going to talk about is the compressor. The compressor is the heart of the system, and this is what compresses the gas and circulates it around the system. It goes through the condenser coil, through the capillary tube, back through the evaporator, and is sucked back through the suction in the compressor. The condenser is a heat exchanger in a window air conditioner, where the heat is rejected into the atmosphere. It has got fins, aluminum fins, on copper tube, and with the air blown over it, is rejected out to the atmosphere. Now we'll talk about the evaporator coil or the cooling coil. The construction of the evaporator coil is similar to that of the condenser. We have aluminum fins pressed over copper tubes running within it. You can see the copper at both ends. What is the purpose of this evaporator or cooling coil? We are drawing the room air over a filter and cooling it. Now the refrigerant is within the pipe. The air is flowing over the aluminum coils or fins. Fixed over the pipe, the air gets cooled. The refrigerant is within the pipe gets heated. There is a heat exchange between the air and the refrigerant. This refrigerant, which is heated, goes back to the compressor. The air, which is cooled, goes through the blower and back into the room. Now we'll talk about the filter dryer or the strainer dryer. What is the function of this small component? Like the name goes, it filters or strains the refrigerant which is forced to pass through it and dries it. If there is any dust, any dirt in the refrigerant, it is captured at this point and doesn't go into the system or the compressor. It also dries the refrigerant. Now if by any chance there is a slight trace of moisture, it absorbs it. How does it do this? It's got silica gel packed in it, and silica gel is a very hygroscopic, moisture absorbing component. This is the capillary tube and is fitted just after the strainer dryer. What is the purpose of this capillary tube? It is a very fine bore copper pipe which creates a pressure difference between the condenser and the evaporator. So you have a high pressure, high temperature condenser and a low temperature, low pressure evaporator or cooling coil. This creates sudden change, we can say an expansion of the refrigerant before it goes to the evaporator, where it suddenly cools. So far we've been talking about the window air conditioner. Now we are going to see the split air conditioner. Now what is this split air conditioner going to be? This particular portion is the indoor unit. This unit has a major advantage. In fact, there is no noise. This is a very silent unit. Another advantage with this machine is you do not have to make an opening in the wall or any damage to the structure. Just a small hole of approximately 3 inches will carry the refrigerant pipe from this unit to the outdoor unit. Now what is this outdoor unit? It is placed outdoor. It is having a condenser fan. It has a blade and the condenser coil. In addition to the main component of the heart called the compressor. This is what is going to make the noise. So in this split unit, we have expectedly kept the noise outside and the cooling inside.
Check and test capacitor, relay, OLP, thermostat and fan motor of window AC. Required tools: test board, test lamp, line tester, screwdriver, cutting pliers and multimeter. Materials: air conditioner, capacitor, relay, OLP, thermostat, selector switch and fan motor.
Now we're going to talk about the start capacitor. This is a very important component in a window air conditioner. This does not connect all through. It only comes when the compressor starts. What is the purpose of this? When the compressor starts, it needs a little bit more push, a little bit more torque because of the friction of the bearings. So this start capacitor gives that additional torque. Now once this torque is given, it has to be disconnected. Here is the run capacitor. Now this run capacitor is always in the circuit, and this maintains slightly higher voltage rating so that torque is always maintained. In electrical terms, it maintains the power factor for the compressor, so it has uniform torque available.
Test capacitor by spark test method.
Prepare the test board. Connect probe A in capacitor 1 terminal. Connect probe B in another terminal. Connect the cord wire to the power source. Switch on the test board for a few seconds and switch off. Hold the plastic handle of the screwdriver and short the terminals of the capacitor. If the capacitor is satisfactory, an intense spark will occur. A weak spark will indicate a defective capacitor. Now I am going to talk about the relay. Now what is the function of this small black box relay? Basically, it is to switch on and off the capacitor. A start capacitor need not be in the circuit at all times. At the time of start, the relay connects the start and the run winding. After the required speed of the compressor is attained, the start capacitor is disconnected. So the basic purpose of this relay is to permit the start capacitor to be fixed in the circuit, and once the compressor reaches its speed, disconnect it. That is the purpose of this relay.
Check the condition of relay.
Connect the test lamp to number 5 on the relay and S, that is the start winding, to compressor before switch to cool. Observe the light. It will give a less glow. If the compressor does not take start, check for other electrical defects. Now we'll talk about the overload protector. This overload protector is fixed on the body of the compressor, and when it senses the temperature, when the compressor gets too hot, it has got a bimetal fix within it. This bimetal, sensing the heat, if it is too much, it opens. And when it opens, it cuts the circuit to the compressor. So the purpose of the overload, like the name, overload, it cuts out the compressor when there is too much of current or too much of heat giving on with the compressor.
Check overload protector by using 220 volts.
Take an overload protector. Take a test lamp, plug it in the test board and switch on. Touch one lead to OLP number 1 and the other to the second and third terminals. If the bulb glows, the overload protector is good. Now I'm going to talk to you about the thermostat. The thermostat is one of the main components of a window air conditioner or any air conditioner. Now what is the purpose of this thermostat? The purpose of this thermostat is to regulate the temperature in the room. So as the air comes in contact with this bulb, it is cooled, and if it is below a set point, an electrical signal from the thermostat goes to the compressor and switches it off. Once the compressor is switched off, there is no cooling, so the temperature goes up again. As the temperature is being drawn over this bulb, the temperature goes higher and the signal is sent again and the compressor switches on. Of course, the main function is regulating the temperature between a particular fixed point.
Carry out test on thermostat.
Crush ice cubes and place it in an insulated container. Mix some salt to the crushed ice cubes. Insert a thermometer inside the container. Take a thermostat and check electrical contact points. If necessary, clean the contact points with fine sandpaper. Connect two wire leads to the thermostat. Connect a bulb in series with thermostat. Connect the other end wire leads with 2-pin plug and plug it in the test board and switch on. Check that the light glows when the knob of the thermostat is not in the stop position. If the light is not glowing when the knob of the thermostat is in stop position, adjust the knob to on position. Watch the reading of the thermometer. See that the bulb glows all the time. Wait until the thermostat goes to cutoff, which will be indicated by off position of the light. Quickly take the reading of the thermometer. Remove the thermal bulb from the ice cubes. Hold the thermal bulb by hand and warm it when the thermostat goes to cut-in position, which will be indicated by the glowing of the bulb. Repeat the steps for 3 readings and note the temperatures carefully and record in table. The fan motor. What does this do? Like the name goes, it handles 2 fans. The condenser fan and the evaporator fan or the blower. They are fixed on either side of the motor. So now this fan motor causes both the blowers or fans to operate and move the air either over the condenser coil on one side and the evaporator coil on the other side. Now we also have the operation of a high cool and a low cool. What is this, or how does this happen? We change the setting of the motor with a different winding, increase the speed of the motor, so we have a high cool, and we want less noise and less flow, we go into a low cool.
Carry out a test on fan motor.
Prepare test cord with a 200 watts bulb in series. Plug the test cord to test board and switch on. Touch both leads. If the bulb glows, the circuit of test cord is completed. Disconnect electric supply. keep the unit on the workbench, plug the unit in test board and switch on the switch. On the fan switch, if it is run, the fan motor is in good condition. As mentioned earlier, the compressor is the heart of the air conditioning system. And if the system doesn't work because the compressor is not working, what does one do? Now we have to check for the compressor. There are three possible outcomes. One is the compressor is burnt out. The second thing is that it is mechanically stuck. And the third thing is there is no voltage at the compressor. Now we have to analytically check the compressor working by taking resistance readings at the terminals. It could either be a single phase compressor or a three phase compressor. If it is a three phase compressor, the resistance between any of the two terminals will be the same. For a single phase compressor, if you take the resistance readings between each of the three terminals, the sum of any two terminals will equal to the third.
Check the windings of the AC compressor with test lamp and multimeter. Required tools: multimeter, test cords, test board, and a test lamp. Equipment: a window AC. Check the terminals of the compressor with the test lamp.
Switch off the compressor if it is in on position. Remove the compressor terminal cover. Remove the terminal wires and label it. Test the test lamp and plug it to the test board. On the test lamp switch and touch the leads to check lamp. Touch the test lamp lead to compressor C terminal and other to S terminal. If the bulb will give less glow, the start winding is in good condition. If the start winding is open, that is no continuity, the bulb will not glow. If it is short, it will glow bright. Remove the test lamp from S and touch it to R terminal. If the bulb will give bright glow, the run winding is good. If it is not, the running winding is open.
Check the terminals of compressor with multimeter.
Fix black lead of multimeter in common point and red lead at range point. Set the multimeter knob to ohm scale. Put the black lead on any one of the terminal. Touch the red lead on the compressor body. When the multimeter shows any value, there is a chance of the compressor is grounded. Continue checking of winding resistance across other terminals like C and S, C and R, R and S. Compare the resistance values with the manufacturer's data. Here I am going to talk about the airflow in a window air conditioning machine. In air conditioning, we normally control three aspects: the temperature, the humidity, and the airflow. Now, by controlling all these three parameters, we give a comfort condition to the people within that space. In this, the airflow is one of the most critical in air conditioning. Just imagine if you are in a AC room and you have a blast of air coming, you're going to feel shuddering, you're going to feel a cold. Or if you are in an AC room and there is no much movement, again you're not going to be comfortable. So it is important that you have a certain amount of waft or flow of air around you. To maintain this waft of flow of air, what is it that is required from the machine? Let's say we have a 1-ton air conditioning unit. A window air conditioner 1 ton should give close to 300 cubic feet per minute of air. This kind of airflow will give a throw. A throw, I mean, is the air from the grill to the last point where the air comes to more or less a standstill. That should be close to 10 to 15 feet.
Measure the velocity of airflow in window AC. Required tools: velocity meter, measuring tape, stopwatch, cutting pliers, and a screwdriver. Equipment: a window AC in working condition.
Switch on the air conditioner. Select the switch in high cool, that is high speed. Wait for a minute till constant speed is reached in the fan motor. Hold the velocity meter tube or anemometer in front of the grill as shown. Release the lock from the velocity meter and at the same time start the stopwatch. After a minute, stop both and record the reading in the record sheet. Check the flow at grill 1 to 6 points and record the readings in record sheet. Measure the air outlet, grill area, length and breadth with a measuring tape in feet. Measure the luvers. Calculate the net area and record it in the record sheet. The total area minus the louver area is equal to the net area. Find the air velocity and record in CFM. Velocity into area is equal to CFM or cubic feet per minute. Convert the cubic feet per minute to cubic meters per minute and record in record sheet. CFM into 0.0284 is equal to cubic meters per minute. Compare the airflow with the nameplate detail.
Flush contamination and condenser and evaporator of window AC. Required tools: screwdriver, cutting plier, charging hose of 6 mm, nitrogen cylinder with 2-stage, pressure regulator, adjustable spanner, and a valve key. Equipment: condenser coil of AC unit, evaporator coil of AC unit, flare nut of 6 mm, flare union of 6 mm, pressure regulator.
Fix a flare nut 1/4 inch or 6 mm at the inlet tube of the coil. Connect a brass union with the flare nut. Connect one end of the charging hose to the regulator of the nitrogen cylinder. Connect another end of the charging hose to the brass union of the coil. Open the cylinder valve with cylinder key. Keep the hand at the outlet tube of the coil. Regulate the nitrogen pressure in the regulator to 100 psi gauge, that is 7 bar. Notice the nitrogen gas is coming out of the outlet tube of the coil. Close the outlet tube by using the thumb of the hand and hold the gas inside till maximum possible limit, that is 2 to 3 seconds. Open the outlet tube by removing the thumb. That is 5 to 6 seconds. Repeat the process till all impurities draining out. Remove the hand from the outlet tube of the coil. Loose the regulator knob and close the nitrogen cylinder by valve key. Fix a flare nut, 1/4 inch or 6 mm at the inlet tube of the coil. Connect a brass union 1/4 inch or 6 mm with the flare nut. Connect one end of the charging hose to the regulator of the nitrogen cylinder. Connect another end of the charging hose to the brass union of the coil. Open the cylinder valve with cylinder key. Keep the hand at the outlet of the coil. Notice the nitrogen gas is coming at the outlet tube of the coil. Close the outlet tube by using the thumb of the hand and hold the gas inside till maximum possible limit, that is 2 to 3 seconds. Open the outlet tube by removing the thumb. Repeat the process given above at uniform intervals, around 5 to 6 seconds. Notice any impurities, contamination, CTC liquid, trichloroethylene liquid which are coming out at the outlet of the coil. Repeat the process till the impurities coming out are drained. Remove the hand from the outlet of the coil. Loose the regulator knob and close the nitrogen cylinder by valve key.
Replace dehydrator in window AC. Required tools: trainee skip, gauge manifold, pressure gauge, compound gauge, tube cutter, flaring block with yoke, bracing proper rod with flux, oxyacetylene with bracing torch, goggles, spark lighter. Equipment: service cylinder with F22, 6 mm dummy nut, vacuum pump, 6 mm copper tube, bracing copper rod with flux, and filter dryer. Check and replace faulty filter dryer.
Cut off the charging line in compressor for vent the refrigerant from the system. Attach a hand shut-off valve to the charging line. Connect a gauge manifold set into the system. After vent the refrigerant from the unit, remove the dryer solder joints or the brazing joints with a brazing torch. Flush the lines with nitrogen. Braze the new dehydrator with liquid line and capillary tubes with copper brazing rod. Charge a small amount of refrigerant by the charging line. Leak test at brazing joints by soap solution. Braze the charging port properly.
Pressurize and leak test in window AC. Required tools: training kit, nitrogen gas cylinder, charging pipe of 6 mm, welding rod, welding flux, welding safety glass, gas welding set, tube cutter, flaring tool and swedging tool. Equipment: water tank, soap water and brush. Leak testing window AC. Find out the leak spot and debrazing the leak spot in window AC.
Stop the unit. Disconnect main cord from the supply. Remove the given window AC from the outer cover and place it on the work table. Connect the gauge manifold through charging line with 1/4 inch turned pipe and other end of 1/4 inch pipe to pressure regulating outlet valve of nitrogen cylinder. Apply soap water on all the joints at window air conditioning unit and locate the leak spot by seeing bubbles. In case of leak detection in condenser, cooling coil and in any other place which is not visible to check leak by service mechanic, remove the relevant part and braze one end and connect the other end with 1/4 inch pipe and close cylinder valve and service valve immerse in water tank. This will help to find out any minute leak in the system. After the leak is detected, mark the area, then clean the leak spot with rough emery. Apply flux on the joint using blowtorch. Braze the joint with necessary brazing rod using oxyacetylene cylinder.
Evacuate and charge gas to the window AC. Required tool: vacuum pump, heating kit, gauge manifold, charging hose, cutting plier, online tester, double-ended spanner, adjustable spanner, and a ratchet key. Equipment: a window air conditioner. Handle and operate vacuum pump.
Connect one end of the charging hose to angle valve of the high pressure side condenser outlet and connect the other end to HP high pressure port of gauge manifold. Connect one end of charging hose to the angle valve of low side and connect the other end to the low pressure port of the gauge manifold. Connect one end of the charging hose to the intermediate port of the gauge manifold and connect the other end to inlet of the vacuum pump. Make sure that the HP LP knobs of gauge manifold should be closed. Confirm the electrical power supply available to the vacuum pump by using an online tester and voltmeter multimeter. Plug in the power line of vacuum pump to the power socket. Switch on the vacuum pump. Observe the reading available in the compound gauge of manifold. Ensure the pressure is reducing. Leave the system as it is for 3 to 4 hours without any interruption. Close the angle valves of HP and LP side. Stop the vacuum pump.
Charge refrigerant into the system.
Open partially the low side and high side angle valves one by one. Observe the refrigerant flow also in low pressure and high pressure gauges and ensure that it is increased from vacuum low pressure gauge and zero level high pressure gauge to above 0 psi gauge onwards. Observe the hissing noise into the compressor during the pressure is increasing from vacuum to above positive pressure level that indicates the vacuum is broken. Open the service cylinder valve fully. Fully open the valve knobs of HP and LP sides of the manifold. Allow the refrigerant flow till it reaches to 30 to 50 psi gauge in the LP gauge of manifold. Then immediately close the angle valve of both sides. Test the electrical power supply available to the appliance is in operating limits, that is 180 to 230 volts, using a multimeter. Open the low side valve to allow refrigerant to be sucked in by the compressor. Observe the pressure readings on both low pressure and high pressure gauges and current drawn by the appliance or the system. Allow the refrigerant flow till sweating or the moisture condensation of suction line on suction and discharge pressure reaches to the desired limits. Close the service cylinder valve using ratchet wrench and cap with dummy nut. Close the low side angle valve and LP valve knob of manifold. Remove the charging hoses 1, 2, 3 from whatever they are connected. Test the cylinder valve for any leaks using soap solution.
नमस्ते दीदी, आप इस बार किस प्रकार की ऑनलाइन सेवा उपलब्ध करा रही हैं?
नमस्ते रोहन। इस बार मैं आपको विभिन्न प्रकार की सिटीजन सेंट्रिक सर्विसेज जैसे बैंकिंग सुविधा, बीमा सुविधा, कास्ट सर्टिफिकेट जारी कराना, रेसिडेंट सर्टिफिकेट की जानकारी इत्यादि उनके ऑनलाइन पोर्टल के माध्यम से बताने जा रही हूँ।
ये दिलचस्प लग रहा है। दीदी, कृपया मुझे बताइए कि मैं इन सुविधाओं को कैसे इस्तेमाल कर सकता हूँ।
बिल्कुल रोहन, चलो विभिन्न प्रकार के ई डिस्ट्रिक्ट सेवाओं से शुरुआत करते हैं, जिसमें कास्ट सर्टिफिकेट, रेसिडेंट सर्टिफिकेट और इनकम सर्टिफिकेट का जारी होना शामिल है।
नमस्ते गीता, मुझे मेरा कास्ट सर्टिफिकेट कैसे मिलेगा, इसके बारे में क्या आप मुझे विस्तार में बताएंगी?
हाँ बिल्कुल, कास्ट सर्टिफिकेट की सुविधा भारत सरकार भारतीय संविधान के अनुसार विशिष्ट जाति या उपजाति के भारतीय नागरिकों को विशेष योजनाएं और आरक्षण जैसे फायदों के लिए उपलब्ध कराती है। कास्ट सर्टिफिकेट पत्र के आवेदन के लिए आप इन चरणों का अनुसरण करें। पहले ई एप्लीकेशन फॉर्म को डाउनलोड करें। फिर बिना कोई गलती किए सारी जरूरी डिस्क्रिप्शन भरें। उसके बाद अपने किसी भी नजदीकी नोटरी के पास जाके इसे नोटराइज्ड करवाएं। अप्लाई करने से पहले एक बार फॉर्म को अच्छी तरह से पढ़ लें।
क्या मुझे अप्लाई करने के साथ कोई डॉक्यूमेंट्स लगाने की जरूरत है?
हाँ, आपको कास्ट सर्टिफिकेट फॉर्म के साथ ये डॉक्यूमेंट्स लगाने होंगे। कोई भी एक पहचान पत्र जैसे कि वोटर आईडी, पासपोर्ट, ड्राइवर्स लाइसेंस, RSBY कार्ड, आधार कार्ड, सरकार या अर्ध सरकारी संस्थानों द्वारा जारी कराया गया कोई पहचान